I'm Miss Jenny. Welcome to Global Gardens. Here we'll spend time together learning about science, learning about peace, cooking, and being creative together. Before we get started, we're gonna do community circle. And remember, at community circle, we breathe in good things that help us feel happy and full of life, just like oxygen helps us when we take it into our lungs. And we let go of the things that might be weighing us down, might be worrying us, or would cause us to be distracted during this time together, just like we breathe out carbon dioxide. So take a few minutes and reflect. Think about some things that you would like to breathe in and breathe out today. All right, ready? We're gonna take 5 breaths together. Count them with me. Breathe in. Breathe out. 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 Thanks for doing Community Circle with me.
Hey guys, welcome to Global Gardens. Today we are going to be scientists. We are studying chemical and emotional reactions. So before we dive into the experimentation part, first let's think about what does it mean to be a scientist. You might be thinking we need lab coats, maybe some goggles, and some cool little beakers, which you could use those, that would work. But also, I'm a scientist, and you are a scientist, and we can be scientists in our normal, everyday people clothes. So one way that we be scientists is by using our observation skills. We use our observation skills to notice the world around us and see what's going on. Once we kind of see and understand what's going on, we can form conclusions, we can do tests, we can make guesses about what is happening around us in the world. So when we're making observations, we get to do that using our 5 senses. One of them is by feeling, one of them is by hearing, one is through smelling. You can make observations with your mouth by tasting, or through seeing with your eyes, which will be a lot of the observations that we do today. So we talked about being a scientist. To be a scientist, you just have to be curious and observe the world around you. Alrighty, now we're going to dive into some science. So today we are going to do some chemical reactions. First of all, what does it mean to have a chemical reaction? Well, a chemical reaction occurs when you mix 2 different substances together, and after they react together, a whole new substance or a whole new thing comes out. For example, maybe you and your friend. Maybe you are quiet and you're reserved. You're not very loud. Maybe even sometimes you can be shy. Maybe your friend is the same way. When they're by themselves, maybe they're quiet too. No one really notices them. Maybe they're timid. But when you and your friend, who are normally quiet by yourselves, when you guys get together, you start being loud and goofy, and you're yelling and you're excited and you bounce off ideas with each other, and you're reacting together. So even though before and separately you guys were quiet and reserved, when you got together, you got loud and excited. You were like a whole new person. So that's similar to our chemical reaction. A chemical reaction is where you mix any 2 different things and they react together and a whole new thing comes out. So let's do some chemical reactions, yeah? Now, you're welcome to do these science experiments at your house, but make sure that when you do them, you're being careful, you're being observant, and that you let your parents know. These experiments we're doing today are going to be messy. And so one way we're going to help control some of the mess is I have this tray to catch any liquid that might explode out, and I'm going to take careful measurements of everything I put into my experiment so that it can be the same across the board, but also so that it'll be a little more controlled than me just pouring things and mixing together and seeing what happens. So for our first science experiment today, we are going to be mixing white vinegar with baking soda. Now before we get started, I kind of just want to show us what these different things are. Here is some baking soda. What do you observe or notice about it? What do you see? I see that it's white and a really fine powder. While I'm feeling it, I'm feeling that it's really soft. If I try to smell it, I'm not really smelling too much. And I don't want to taste it. I already know that baking soda doesn't taste very good. Baking soda is often used for baking cakes. It helps our cake or our bread to rise and get fluffy. So baking soda is often used in baking. You can also use it to help clean maybe really hard to get dirt off of pots and stuff. Our vinegar here is often also used as a cleaning supply, whether to clean your microwave or to clean your oven or to clean your floor. But you can also cook with white vinegar as well. So like I said before, I'm going to go ahead and measure out all of our ingredients for our science experiment before we get started. So I've gone ahead and measured out 1/8 cup of baking soda and put it in each of my beakers. I will also be adding a little bit of food coloring to a couple of my beakers. I'm going to add blue to this one, and this is either yellow or red, I'm not sure, to this guy. By adding the food colors, I'm hoping to highlight more of the chemical reaction, but I'm also going to leave one plain one so that we can see what would happen naturally. Alright, we've already measured out the baking soda. We have 1/8 cup of each. I'm going to go ahead and measure out 1/2 cup of white vinegar. And I'm going to go ahead and measure out 3 different 1/2 cups of white vinegar. That way I can add it to each of the experiments almost at the same time. That way we can see the reaction in real time. Like I said, I'm also going to add some food coloring. And I'm doing that mostly because it's fun to see the different colors, but also it's scientific to be able to observe what happens, and it might help highlight some of the reaction that is occurring when we mix these substances together. So, just gonna add a couple drops. And remember, I'm gonna leave this third one empty or without food coloring because I wanna see what the original looks like, what it would normally be, and it'll be a good thing to compare the other two against. Alrighty, I'm going to go ahead and add the food coloring. Watch closely what happens. So what happened in that reaction? Well, we added our 2 substances together. Remember, our baking soda and our white vinegar. We mixed them each in these separate jars, and we used food coloring to help us see kind of what would happen. Use your observations. What do you notice about these jars? What are you seeing? Can you see that liquid? Do you see the bubbles that are slowly rising from the bottom and into the liquid? If I was to pick up this tray to show you, you would see that the water on the tray is all bubbly as well. Something that I'm finding interesting is on this tray, you can see this clear line. We have our red substance here and our blue substance here, and they're not mixing. Normally, when you have food color in just water, it would all mix together. But this is not mixing. There's a clear line separating red and blue. I think that's really interesting. Other things I'm noticing is that there's still lots of bubbles in our jar. There's lots of bubbles in this liquid down here. During the reaction, we saw both big and huge bubbles bubble out and overflow from the jar and onto the tray. I'm kind of noticing a little bit of a smell. It doesn't smell nearly as strong as vinegar by itself, but it does smell stronger than baking soda. I'm also hearing the sound of all those little bubbles forming and popping. It kind of sounds like a soda drink, all that carbonation. So I'm hearing that. I could taste it, but I don't think I'm going to today. That doesn't sound good to me. Because I know what both of these taste separately, I'm going to guess that they taste gross when mixed together. Yeah, so that was our very first chemical reaction. So we mixed white vinegar and baking soda, and it formed a new bubbly substance. So that is a chemical reaction. Now we're going to do another reaction. This time I was thinking that we could do water and oil. So our next chemical reaction is mixing water with some oil. These are two different substances, and I want to see what is going to happen if we were to mix them together. So, like before, I'm going to measure out my oil. Here's 1/8 cup. I'm going to add it to the water. Do you notice what's happening when I add the oil? The oil and the water did not mix. You can see on the bottom we have all of our water, and the oil, even though we poured it into the water, it actually has floated back up to the top and has formed a layer of just oil on the top. If you look closely, you can see all these different bubbles in it, but either way, they're very separated. So I could even try to mix them up. Mix them up like this. You can see lots of bubbles, but as we wait, what do you notice? Do you see that once again the water is coming to the bottom and the oil is floating up to the top? So because these two different substances, oil and water, did not mix together, that means they also did not form a new substance. The oil is still separate from the water, and they're not a new thing. This means that oil and water do not make a chemical reaction. So unlike our baking soda and vinegar that reacted together and became a new fizzy liquid, oil and water do not mix, and there was no chemical reaction here. So that makes me kind of curious. If oil and water don't cause a chemical reaction, but baking soda and vinegar do, is there some kind of rule about what we can mix together to make a reaction or an experiment form? There actually is, yes. So the way this works is vinegar is something called an acid, and baking soda is something called a base, or is basic. Acids and bases, when you mix them together, will form a reaction. Water and oil, however, are not acids or bases. They are neutral, and so when you mix them together, they don't do anything. But vinegar is an acid, baking soda is a base. There are some other household acids that you might be familiar with. Lemon juice, for example, is an acid, and coffee is an acid. What kind of things do these acids have in common? Acids all have kind of a slightly acidic or a sour or a bitter taste. Think of lemon juice or a lemon, for example. When you bite into the lemon, your face kind of puckers up because it's so sour. So that same acidity in lemon juice is also in coffee or vinegar. These three things are all acids, and they react when you put them together with a base. So our acids are things that are going to be sour. Our bases might be like baking soda. It could also be soap. It could also be bleach. Those are examples of bases. What do these three bases have in common? Well, one thing about bases is that they're all kind of slippery. So our baking soda, because it's a powder, it's a little harder to define it as slippery, but in your hands it kind of has a smooth feel. Same with bleach. If you ever got bleach on your hands, which isn't good for you, but it kind of also has that slippery, slick feel. It feels like it could just run right off your hands. It's very kind of slippery and weird. Same thing with soap. Maybe you guys notice it when you're washing your hands or you're cleaning dishes. Soap is slippery. So all these three things are bases. Bases are slippery. Acids are sour. So anything that's sour is going to react with our bases. So that is why our baking soda and our vinegar reacted when we added them together. There are different levels of reactions that occur based on how acidic or how basic our substances are. For example, if you add something that's super acidic to something that is super basic, when you mix them together, there is going to be a larger reaction. Or if you added something that was just a little bit acidic to something that's just a little bit basic, it's not going to cause as big of a reaction. So one way that we can measure or tell the difference of our acids and basics and how strong they are is by using a pH scale. Our pH scale, as seen here, outlines the levels of pH or acidity that different substances have. If we start in the middle where it's green and it says neutral, that would be the acidity of water. Water is not acid. But as you move farther to the left and the colors become a bit warmer and you're moving towards red, that's when things become more and more acidic. So on the far left, you're going to see battery acid, stomach acid, Coke, tomatoes. When you move to the far right, that is where things are more basic. Bleach is the most basic thing on there. Now that we've explored our pH scale, we're going to do another chemical reaction. This time we're going to do one with 2 substances and 1 catalyst. First, our substances are hydrogen peroxide and dish soap. According to our pH scale, hydrogen peroxide is a weak acid. Dish soap is a weak but slightly stronger base. When we mix hydrogen peroxide and dish soap together, they have a very slow reaction. That means it would take a long time for us to really see what's going on. So we are going to add a catalyst. Our catalyst today is yeast. Yeast is a catalyst, and what I mean by that is, it speeds up the reaction. So when we mix hydrogen peroxide and dish soap, and then we add our catalyst, our reaction is going to be sped up. So we'll actually be able to see what would normally happen, but just in a shorter amount of time. So first of all, I'm going to measure out 1/2 cup of hydrogen peroxide. Remember, we do measurements in order that we can better control our experiment, and that way it's not quite as messy as it could be otherwise. So 1/2 cup of hydrogen peroxide will go in here. I'm also going to add a few squirts of dish soap. Now if you look, you can see the dish soap is kind of swirling around, but I'm not seeing any super intense reactions. Nothing like the baking soda and the vinegar. In this cup, I have some warm water and I've mixed some yeast in. I'm going to go ahead and add a little bit more yeast though. I want to show you guys what it looks like first. Do you see our yeast? They're little tiny cylindrical shapes. Yeast is actually a type of fungus, so it is alive, and they're super important in our environment. They help break things down. And so just like in the rest of our environment, yeast helps break things down. That's what it's going to do in this reaction as well. So first I'm going to stir it up. Now I want us to take notice. What color is our dish soap and hydrogen peroxide? It's pretty clear, slightly yellow. What color is our yeast? It's kind of like a milky, almost brownish color, but not very dark. Now, I'm going to add some food coloring, but kind of just for fun. But I'm going to do it in a couple stripes, and I want you to observe what happens to the food coloring before and after our experiment. Okay. Now I'm going to add the yeast. It's all been mixed up with some warm water. I'm going to add it to the hydrogen peroxide and dish soap. Remember, our yeast is a catalyst. Its job is to make the reaction happen faster. What do you guys notice about this foam? It's pretty dense. You can kind of see how the blue food coloring that I added in, it came up in stripes and then it mixed completely in. If it hadn't been for the blue food coloring, what color do you think this substance would be? So, we just did an awesome experiment where we mixed hydrogen peroxide, soap, and yeast together to create a big bubbly mass of elephant toothpaste. Now, is it really toothpaste? No. Should you brush your elephant's teeth with it? No. But it definitely looked cool, didn't it? Can you think of any ways that we could have done the experiment differently? What would have happened if we used different shaped bottles? Or used more or less yeast? Or used more or less hydrogen peroxide or soap? What would have happened if we added different colors of food coloring? There are so many questions and things we could ask and different types of experiments that we could do. But you know, we don't just find chemical reactions in the science lab. We also see them in everyday life outside. For example, plants, they do chemical reactions all the time. Plants use the sunlight plus carbon dioxide plus water, and in their bodies, it forms a chemical reaction that turns into plant food, or ADP. Also, chemical reactions could be found in your fridge. Like when you leave milk out too long and it turns sour, and then you smell it and it's like, whew, or you go to drink it and it's really chunky. A chemical reaction happened right in your milk jug. Other chemical reactions might be when you're burning wood. Or have you ever found rust, that red flaky stuff on iron? That is the iron interacting with oxygen. Those two substances, when they mix together, they form rust. So chemical reactions are happening all over the place. And another place they're happening is right here in us. Well, not chemical reactions, emotional reactions. Just like how we talked about before, where two different substances mixed together form a chemical reaction, that can happen to our emotions as well. Sometimes our situations plus ourselves mixed together form this crazy concoction of feelings, stuff that bubble outside of us. Sometimes we even have emotional catalysts. Like, have you ever got angry and yelled at someone that you're not actually angry about? Or have you ever cried and been sad at something that you're not actually sad about? It sounds like an emotional catalyst got dropped in on your mixture. So, emotions are funky things. Sometimes they can be like a bottle of soda. we stuff our emotions in and in and in, and we're just filling them into this bottle, and it's stuffed in there, and it's stuffed in there, and stuffed in there, and stuffed in there, and we're bottling all of our anger. We're never letting it come out. We're just keeping it bottled up. Well, you guys know what happens when we shake up soda bottles, don't you? What happens? They explode. So I'm not going to do this, but if I was to open this after shaking it really hard, it would explode all over this room. So similarly with our emotions, if we bottle up our emotions and just keep them inside and we don't manage our emotions, they one day just explode whenever a catalyst comes by, maybe a situation or a person or someone just says a tiny little thing, and it just makes you go crazy because you bottled up all those emotions and you didn't manage them. So today we're going to talk a little bit, how do I observe my emotions, how do I manage emotions, and how do I regulate emotions? Sometimes emotions can be hard. They can be difficult, confusing, challenging, scary even, but we need to remember that no emotion is good or bad. All emotions are helpful indicators of what is going on inside of you and in the world around you. As emotional scientists, we get to observe our emotions and we get to observe their emotional catalysts, or what makes you feel that way. And we get to wonder, why does that make me feel that way? And we get to make conclusions like, that makes me feel that way because, and you get to decide, do you like that or not? Just like we use the pH scale to measure out the difference between acids and bases and which are more extreme, we as emotional scientists get to use an emotional mood meter. Our emotional meter has 3 different colors. We have red, green, and blue. Remember, no emotion is good or bad. They are all indicators of what's happening inside us and in the world around us. These 3 different colors correspond to different emotions or feelings that we might have. Our blue color corresponds to emotions or feelings of sadness or disappointment or even just being tired. Often when you're feeling this way, your body slumps like this and maybe your eyes are looking down. Our green color indicates being happy or calm, when you're just in a good mood and you're just neutral. This could include when you're in a good mood, when you're just neutral, maybe when you're excited, maybe when you're patient. That would be the green zone. Our red zone is when you're feeling angry or mad or frustrated. Often when you're in the red zone, you're going to make faces like this, or you're going to make fists because you're upset. Now, once again, all these colors are neither good or bad. They are just indicators. However, we learn the best and our brains work the best when we are in the green zone. And this tends to be a zone that people most enjoy being in. So we often want to be in the green zone, and it helps our brains function and learn the best. When we're in the blue zone, remember that was when you're feeling sad or disappointed or tired. There's a couple things we can do to help us move back into that green zone. If you're sad, something you can do is talk to someone that you trust. Tell them why you're sad. Sometimes just talking about why you're sad really helps your brain process and is able to help you become more calm and more content with what's going on. If you're in the blue zone because you're tired, sometimes going on a walk, getting some fresh air, that'll help you feel less tired and move you again into the green zone where you have a little bit more energy. Now, if you're in the red zone, remember that referred to when you were feeling angry or upset. Maybe your mind feels really confused and our body is often tensed up. And so what we want to do to get back into that green zone is relax our body. So one way we do this is by taking breaths. One really good picture for doing this is pretend you're holding a flower in your fist. Go ahead, if you're watching, do this with me. Even if you're in the green zone, it's so good to take these breaths. So no matter where you are in these zones, go ahead, hold a fist, and pretend in your fist that you're holding a flower, a beautiful flower. And now we're gonna smell the flower, so smell it really deeply. Okay, now we're gonna turn the flower into a candle. So pretend your flower is now a candle, and we're gonna blow out the candle. Good. Now we get to do it 2 more times. So use your fist, you're holding a beautiful flower, and smell it. And now candle. Blow it out. Let's do that again. Smelling that flower, and now blow out the candle. How does your body feel after you've done that? For me, I was in the green zone, and now I feel even more relaxed than I did before. If you were in the red zone and you were feeling really tense when you took those breaths, that helped you, hopefully, calm down a little bit, relax your muscles, and hopefully give your brain some time and some space and some air. Sometimes when we can't think, when we're not thinking very well, it's because there's a lack of oxygen to our brain, and so it's really helpful just to take in some deep breaths and restart that flow of oxygen so we make sure everything is working and that we're able to think clearly. Now, some other ways that we help regulate or manage our emotions, or move them from blue to green, or move them from red to green, is by talking to someone you trust, is by exercising, so either a walk or going on a run, is by writing them down, so you could journal your emotions. What are you feeling? Why are you feeling them? You could do something creative, do some art, or you could just do those breaths that we practice. Remember, you hold that flower, sniff it, and then you blow out that candle. Those are awesome ways to help us realize what is going on in our minds and in our bodies. Why am I feeling the way that I'm feeling? And it helps us regulate or change those emotions from either blue or red to green, where we're able to be in a better space to be able to process and think about what's going on. I want to thank you guys for joining me today as we were chemical and emotional scientists. I want to challenge you to go ahead and take a moment and think about, where are you on the emotional mood meter? Are you in the red, the green, the blue? What are you observing about your emotions or the activities and actions happening around you? What are ways that you can manage and regulate your emotions to get you back to green so that you can use your full brain capacity? Thanks for joining Global Gardens, and we'll see you next time.